section 5.1, we will learn how to write function rules given tables and real-world situations. So we're talking about story problems here. Okay, we're going to start with example number 1. In example number 1, we are going to write a function rule from a given table. So I'm going to give you 3 different type of examples for writing a function rule from a given table. So in this first one, we are given the domain of 2, 4, 6, 8, and then the range are 8, 10, 12, and 14. So to determine what the function rule is, I'm going to show you some methods that you need to consider when you're trying to figure out what the function rule is. And remember, the function rule, another word for that, is an equation. So we want to write an equation which will create this table. So what we're going to do is we're going to look for the change. What's the change in the y value? So we're going to call that delta y. So this delta y means change. So change in y would be 2 here. So it went up by 2. And then over here again is up by 2. But over here, the change in x, we call that change in x, between here is also 2 and 2 and 2. So between here and here, my change in y over change in x is 2 over 2, which is 1. And we're going to do the same thing again. Change in y over change in x is 2 over 2, which is still 1. And then over here, change in y over change in x is 2 over 2, which is 1. And since these are all the same, we are going to take this number and you multiply by x. So we're going to put the 1 there. So if they're all the same, that's the number you multiply x by. So when we multiply 1 by 2, and we're going to multiply 1 by 4, 1 by 6, and 1 by 8. So it's 1x. Now I want to know what else that I need to do to get to 8. So 1 times 2 is 2. And to make it 8, I need to add 6. And then I'm going to see if this pattern is all the same for the rest of the numbers. So 1 times 4 is 4 plus 6 is 10. So that's true. And then same thing for the rest. So 1 times 6 is 6. 6 plus 6 is 12. And then 1 times 8 is 8 plus 6. So my function rule is given by f of x is equal to, so all these x, y values are 1x plus 6. And this function rule, this equation, will create this table when you plug in your different domain. So in another example, here's my x and f of x. I have 2, 3, 5, 6, and then 5, 7, 11, and 13. So we're going to go through and do the change in y and change in x again. So the change in y and change in x. So change in y is 2 here, and change in x is also 1 here. And then in change in y over here is 4, and then change in x is 2, and then change in y is 2, and change in x is 1. So change in y over change in x over the first set is 2 over 1, which is 2. For the second set, my change in y over change in x is 4 over 2, which also reduces to 2. And then change in y over change in x is 2 over 1, which is still 2. So if you notice this time, 2's are all the same, so that's the number we're going to multiply by x. So when we multiply everything by x values, my domain, 2 times 2 is 4. This time I'm going to need 1 more to make it 5. So I'm going to do that to all of them and see if it gives me the same y value that's there. So 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. 2 times 5 is 10, plus 1 is 11. And then 2 times 6, which is 12, plus 1 is 13. So you can say that the function rule f of x is equal to 2x plus 1. In my third example, my table this time is given by f of x and x. So in this one, my x and f of x is 2, 4, 6, 8, and my f of x is 5, 17, 37, and 65. So we're going to do the change in y over change in x again. Change in y is 12, and then change in x is 2. So change in y over change in x is 12 over 2. And this one is 20, and over here is 2. So change in y over change in x is 20 over 2. And this one is 28, and this is 2. So change in y over change in x is 28 over 2. So if you notice, when I reduce, this becomes 6, this is 10, and this is 14. And they're not the same. But if I did my change here, here, and here, this one I went up by 2. I'm sorry, I went up by 8. And I also went up by 8. And these are the same. So if you have to do the 2 loops to get the same value, the 2 loops tells you that the x is being squared. So this makes it x squared. Okay? So my function rule then would be to square all my x's and see what else I need to make it f of x. So 2 squared is 4. I'm going to need one more, and that makes it 5. 4 squared is 16 plus 1 makes it 17. 6 squared is 36 plus 1 makes it a 37. And 8 squared plus 1, 64 plus 1 is 65. So my f of x is equal to x squared plus 1. So 2 loops make it an x squared. So those are some examples of how to take a table and write a function rule. In example number 2, I'm going to give you a word problem. The journalism class makes $25 per page in advertisement for the yearbook. If the class sells P pages of advertising, how much money will they earn? So in part A, what we want to do is write a function rule to describe this relationship. And then second part is if the class sold 6 pages how much did they make? So second part's the easy part. We could figure out how much the class made by selling 6 pages. But the point of this lesson is to figure out how to write a function rule. So to write a function rule, that means we're going to write an equation. We got to see what the key terms are. So in this case, the journalist makes $25 per page, and they said that P stands for pages, and we're trying to figure out how much money will be made. So I already have one of the variables, so I have to define another variable for the money made. So we're going to use M for money earned. So for money earned will be M. So to figure out how much money I earn from selling P pages, so that means the function M, which stands for money, depends on the number of pages, is equal to, and remember the key term, the word per means to multiply. So we are going to multiply $25 by the number of pages, which is P, so it's 25P. And this is the function rule to represent this situation. So now to figure out how much money I make, all I have to do is plug in 6 for P, so money made with 6 pages would equal $25 times 6 pages. So then $25 times 6 pages, I can make $150. And that's how you determine how many pages, how much money by selling 6 pages. And then in the last example, number 3, Acquire spent $100 to produce CDs of their last performance and will sell the CDs for $5.50 each. The function rule is to write a function rule that describes the profit made from the sale. So if you noticed, they don't give us any variables, so the very first thing you have to do is define. And what we're finding is we want to figure out how much profit is made by selling the number of CDs. So I'm gonna let C be the number of CDs. And we're gonna let P be the profit made by selling the CDs. And if you notice, there's the keyword right here, each, that also means to multiply. So it's $5.50 each CD, so you multiply by the number of CDs. So the profit will depend on the number of CDs sold. So it's $5.50 times C will give me the money earned or money made by selling the CDs. But I'm looking for profit. So profit is where you cover the money that you spent on making or producing the CD, so you got to cover your costs, and anything after that would be your profit. So the money that you earned from selling, and I'm going to take away that $100, and the difference between that will be the profit, because I covered my $100, and now after that will be the amount of profit. So this will be the function rule that would describe the situation.